What is Helmholtz free energy at constant volume in thermodynamics? Have you ever wondered how energy and disorder interact in a closed system? Let's break down the concept of Helmholtz free energy and see how it relates to spontaneity and equilibrium. Helmholtz free energy is a key idea in thermodynamics. It helps us understand the maximum useful work that can be obtained from a system that is kept at constant volume and temperature. This energy is represented by the letter A or F and is calculated using the equation A equals U minus T times S in this equation. U stands for internal energy, T represents absolute temperature, and S is the measure of disorder known as entropy. At constant volume, Helmholtz free energy gives us a clear picture of how internal energy balances with the energy lost due to disorder. When a process happens under these fixed conditions, the change in Helmholtz free energy, denoted as the change in A, equals the maximum work the system can perform. It is important to note that this excludes any work done by changes in volume, since the volume is constant. The formula for this is change in A equals change in U minus T times change in S. Now, let's connect this to spontaneity and equilibrium. In a system where volume and temperature remain constant, Helmholtz free energy tends to decrease during spontaneous processes. This means that the system naturally moves toward states that minimize A when it reaches a minimum. We know the system has reached equilibrium, and no further net work can be extracted under those conditions. Practically, Helmholtz free energy is particularly useful in analyzing situations where volume does not change. This includes chemical reactions in rigid containers or certain condensed matter systems. It helps us predict whether a process can perform useful work without any volume expansion. While Helmholtz free energy focuses on constant volume, it complements another important concept called Gibbs free energy, which applies when pressure is constant. Understanding both helps us see how energy, entropy, and temperature interact in thermodynamic systems. In essence, Helmholtz free energy at constant volume provides a straightforward measure of useful work potential and the direction of spontaneous change. It illustrates how systems balance energy content and disorder, guiding us toward equilibrium.